Find the absolute extrema on the interval -2, 4. Now I'm just going to make a random picture. Okay. In a previous video, we talked about relative maximum or minimum. And relative extrema is like, there's a relative max and there's a relative min, and there's a relative max and there's a relative mean. Well, absolute means, what if I take all of this and just like, we care about between here and here. So which one of these is the absolute maximum? Which one of these is the absolute minimum? You know, the absolute maximum could be right on the interval, or maybe it's not. Maybe the minimum is, I don't know. But now we're adding extra elements to it. So in order to do the absolute extrema, we still have to do the same thing that we would do for relative extrema, and that's find the critical points. First things first, I need the derivative. So y prime is going to equal 4, drop that down, x to the third minus 2x. Okay, drop the 4, make that a 3, drop the 2, make that a 1. So let me factor some stuff out. Set it equal to 0 and factor stuff out. I can bring out a 2x. When I do that, that becomes 2x squared. That becomes minus 1. When you have factors multiply together equaling 0, you're going to use the zero product property, set each factor equal to 0. So 2x equal to 0, divide by 2, x is equal to 0. 2x squared minus 1 equals 0. Add 1. Divide by 2. Take this square root and don't forget about your positive or negative. So my 3 critical points are x equals 0, positive square root of a half, and negative square root of a half. All right, so let's make ourselves a sign table with that one. We've got, let me see, this is y prime. We've got 0. We've got negative square root of a half. We've got positive square root of a half. So I guess the numbers that I can choose to go in between, I don't even know what square root of a half is. Let's consult the internet. What's the square root of a half? Okay, the internet says that this is negative 0.7 something. So why don't I plug in negative 0.5? Why don't I plug in regular 0.5? Why don't I plug in negative 1? And why don't I plug in 1? Now, I'm going to plug it in to the derivative, because by plugging it into the derivative gives me the opportunity of finding increase, decrease, all of that good stuff. Whenever it goes from increase to decrease, it's a maximum. Whenever it goes from decrease to increase, it's a minimum. Okay, so I'm going to plug in negative 1 into the derivative. So that's going to be y prime of negative 1 is going to be 4 times negative 1 cubed, which is negative 4, minus 2 times negative 1. So negative 4 minus 2 times negative 1 is plus 2. So that gives me a negative, so you're decreasing. Okay, if I plug in negative 0.5, y prime of negative 0.5, I'm going to ask Siri to do this one for me because I don't have enough space to do it in my head. 4 times negative 0.5 cubed minus 2 times negative 0.5. All right, it's just positive. So you become positive. 4 times 0.5 cubed minus 2 times 0.5. That's negative. And let's plug in 1. I can do that without my old friend Siri helping me out. That's going to be 4 times 1, 1, 1, which is 4, minus 2 times 1, which is 2, which is positive. So there you have it. All right. So I have a relative minimum. I have a relative maximum. I have a relative minimum again. So this picture is going to look something like this. Okay. It's going to look something like that. Here's the problem, though. What if, like, that is 4? Wouldn't that mean technically, since that part right there is higher than everything else, wouldn't that mean that the intervals 2 could be an option for an extrema? Yeah. So what I'm going to do is I'm going to take my 3 critical points and I'm going to take my 2 intervals and I'm going to plug them into the original equation to see what values I get. The largest value that I get is going to be my absolute maximum, and the smallest value that I get is going to be my absolute minimum. So let's start out with the endpoints. Let's just do it. Okay, y of negative 2 is going to be the same as negative 2 to the positive 4th power, which is 2 times 2 is 16, minus negative 2 times negative 2, which is 4. That gives me 4. No, it gives me 12. Gives me 12. Trying to do too much. All right, so one endpoint, check. The other endpoint, about to check. 4 to the 4th is going to be, I believe that's 256. 4 to the 4th power. 256. 256 minus 4 squared, a fun game, becomes 240. Definitely going to need Siri for these ones. Y of negative square root of a half. Oh, I already know what that one's going to be. Jumping the gun. Or do I? No, I don't. If I do 1 times 1 times 1 times 1, right, I get the square root of 1 on top, which is 1. If I do 2 times 2 times 2 times 2, that's 16. So the square root of 16, I get a 4th on the bottom, minus the square root, negative square root of a half is just a half. So you become negative 3/4? Yeah. No, negative 1/4. A little paranoid about that. What is the square? What is the square root? Oh my goodness gracious! What is the square root of 1/2 to the 4th power? Yeah. All right. I did it right. I did it okay. What's a quarter minus a half? Negative 0.5. All right. Let's plug in 0. Finally, an easy one. You're going to get 0. And if I plug in positive 1/2 in a square root, it's going to give the same thing as that. So this is fun. I have an absolute maximum for sure, and it's u. So my absolute maximum is the point 4, 240, and I have 2 absolute minimums. And my absolute minimum is going to be the points negative square root of a half negative a quarter, and positive square root a half, negative a quarter. Whew, gross. Didn't like it. But it's done, and it's done, and it's done correct and well.